All right, when we last left off, we realized that Savant Arrhenius' method of defining acids and bases, it had a limitation. It didn't help us that OH minus was the only way of classifying a base. So eventually we get to these two guys, Bronsted and Lowry, and we have them to thank for our new definition. They actually have the name together, Bronsted-Lowry. And that solved the problem of how do we classify bases. So Johann Bronsted, he was a Danish physical chemist, and Martin Lowry was an English chemist, and they each independently redefined how we look at our acids and bases. So they were living and working at about the same time period and came to the same idea about how to classify acids and bases. So that's why we call this the Bronsted-Lowry theory. And what it's based on is that acids and bases are based on the movement of the protons. Okay, so acids are your proton donors, bases are your proton acceptors. Okay, so let's see what that looks like. So proton is a positive ion, okay, it's a positive ion, and the most common positive ion is H+. So when we're talking about protons, we're going to say H+ is what we're talking about when we're talking about protons. Okay? And so you're looking at the movement of your protons in your reaction. Okay, acids are going to be things that donate protons, that give off their protons because they have extra. Okay, bases are things that are going to be accepting protons because they want more protons. There are a couple other terms that we have to think about while we're learning about acids and bases, especially with the Bronsted-Lowry method, and they're called a conjugate acid and a conjugate base. So what they talked about is you have your protons. So here we've got our acid right here, and this proton is actually going to get moved over to the water. Okay? So your Cl is left by itself over here, Cl minus, and this water picks up an extra proton, which you can see by the H3O+. Okay, so it picks up an extra hydrogen. So what we have is we have to come up with a way of calling these products. Okay, our reactants are going to be your acid and your base. Okay, but your products have to have a name too, and they're called conjugates. Okay, so here the HCl partners up with the Cl, okay, because that's the movement of the H+. And then on the other side, let's see if we can get another pen color, the H2O partners up with the H3O+, and that's another conjugate acid-base pair. Okay, so these are called your conjugates, and they each are partnered up with either your acid or your base, and we're going to learn more about that in the next slide. Okay, so your conjugate acid is going to be a product. It can only be a product. Let me get a good color. And it's going to be the product that becomes more positive. Okay, so that means it's the thing that gets the H added to it. Okay, so that means the conjugate acid of this is going to be NH4, and remember it changes the charge to plus. So the conjugate acid of NH3 is NH4+. All right, let's try our second one. A conjugate base. The conjugate base becomes more negative. It becomes more negative. And that's because it loses, it's the thing that has lost the, more negative, okay? It's the thing that has lost your proton, okay? So your conjugate acid is the thing that ended up gaining that proton, and your conjugate base becomes more negative, all right? It loses that proton. So your conjugate base is actually NO3, so I pull off this H, and my charge goes down to -1. So NO3 minus, all right, is my conjugate base. And if you want, you can represent it, and you can say, oh, and then there's this H+, this proton that is there on the side, all right? So that's a conjugate acid and a conjugate base. And this is a skill that you guys are going to be needing to do for your worksheets. So make sure that you have written this down and that you know how to either add a proton to create a conjugate acid or take away a proton to create a conjugate base. Another skill that you're going to need to be able to do is to be able to identify what's your acid, what's your base, what's your conjugate acid, and what's your conjugate base. Okay, so we're going to start out this one. We know that HCl is a very strong acid. We've worked with it in lab, so we know that that's actually what's going to be our acid. It is going to be donating a proton. All right, so our acid is going to be donating a proton. And you see it donates a proton to H2O, which forms this. Okay, so its pair at the end is going to be Cl minus. This becomes more negative. Okay, so that becomes our conjugate base. And I just use Cb to represent conjugate base. All right. Now for our base, water is going to be our base in this situation. Okay, and it's going to be accepting a proton. So it's going to be accepting this proton. Okay, and that means it becomes more positive, and it's going to actually be our conjugate acid. Again, I'm using Ca to represent our conjugate acid. So another skill that you need to be able to do is labeling your acid, your base, your conjugate acid, and your conjugate base. And you should know which ones kind of partner up with each other. What's your conjugate acid base pair? Okay, what's your conjugate acid base pair right here? All right. One last thing to note is that your conjugate acids and your conjugate bases will always be in your products. So I think I've mentioned that before, but your conjugate acids and bases will always be your products, and these will always be your reactants, will always be your acid and your base. But what about water? So we talked about this a little bit before in the last video, and water is just doing its own thing. Okay, so if you look at this first example, you see a proton from water is being removed. So if a proton's being removed, that's kind of like it's an acid. But here, in the second example, we've got a proton being added to it, okay, to form this hydronium ion, okay, this hydronium ion, and it can do that too. So here in this first example, it acts like an acid, okay, but here in the second example, it acts a little bit like a base because it accepts a hydrogen. So which is it? What is it? The answer is it can be both, okay? Water can be an acid or it can be a base. It depends on what it's reacting with, what it's in a solution with. So it has properties that it can act like an acid or like a base. And that's because it can exist as the proton with the H+, okay? It's got the HOH, okay? Your water configuration. Right, your proton and your hydroxide make your HOH, right? If you add a proton to this, it becomes your water. If you add another proton to your water, you get your hydronium atom, which is H3O+. Okay, and that's also stable in a solution. So water is called amphoteric. Okay, amphoteric means that it can act like an acid or like a base. All right, so that's all for now. I just want to remind you guys to write 1 to 2 questions that you have from this material so that we can start it at the beginning of class tomorrow with a good discussion. All right, see you then.